Good day to everyone. So in lesson 2, we have tackled what is speed and coordination. So in this presentation, we will be tackling more the speed, accuracy, and coordination.
The topic is all about principle of speed and accuracy and coordination. But first, let's define what is speed, accuracy, and coordination. Moving on. First, what is speed? Speed, it is the ability to move our body swiftly. Speed is a physical aspect that has a direct connection with the muscular system and nervous system. What is accuracy? Accuracy is defined as the condition or quality of being precise or exact. Last one is coordination. So, coordination, it describes the synchronization of our senses and our body parts in a way that enhances our motor skills.
So now let's discuss FITTS law. Psychologist Paul FITTS from 1912 to 1965 published his theory on human mechanics and aimed movement in 1954. FITTS used a paradigm in which the participant tapped alternately between two target plates as quickly as possible. The separation between targets, or termed A for movement amplitude, and the width for targets, termed W for target width, could be varied in different combinations, and FITTS law states that MT is constant whenever the ratio of the movement amplitude to target width remains constant. So very long movements to wide targets require about the same as very short movements to narrow targets. In addition, FITTS found that MT increased as the ratio of A to W increased by either making a larger making W smaller or both. He combined these various effects into a single equation. MT is equals A plus B log base 2 times 2 amplitude over width, where A is the empty intercept and B is the slope are constant, and A and W are defined as before. The term log base times 2 amplitude over width is referred to as the index of difficulty, or abbreviated ID, which seems to define the difficulty of the various combinations of A and W. Therefore, FITTS law says that MT is linearly related to the log base 2 times 2 amplitude over width, or simply, the MT is linearly related to the index of difficulty. Now, let's discuss FITTS topping task, which is FITTS most well-known experiment. Ask participants to make movements of a handheld stylus between two target plates, and the goal was to alternately tap each target as quickly as possible while making as few errors as possible. However, the target tapping paradigm was not the only way that FITTS studied rapid aiming. There are two tasks used in the experiment, which are the disc transfer task, which is the goal is to move small metal disc with hole in center, or like carpenter's washers, from one peg to another. And the pin transfer task, which the goal is to move small pins from one hole to another. In both of these task variations, FITTS redefined target width in terms of the tolerance between the disc and target pegs of the diameter of the holes in the plate in relation to the diameter of the pin.
Speed-accuracy trade-off. An important point is that Fitts' law describe the tendency for performers to trade speed for accuracy in what has now become the typical feat tapping task. Participants are told to minimize the number of target misses. In other words, they are instructed to adjust empty so that the errors are acceptably small. Thus, when the target size is increased, the accuracy requirements are relaxed and empties are smaller than when narrow targets are used, which lead to the notion of speed-accuracy trade-off. Speed-accuracy trade-off is the tendency for people to sacrifice or trade off speed in order to maintain acceptable levels of accuracy as one of the most fundamental principles of movement behavior. Speed-accuracy trade-off is also described as the complex relationship between an individual's willingness to respond slowly and make relatively fewer errors compared to their willingness to respond quickly and make relatively more errors. Linear versus logarithmic speed accuracy trade-off. Linear speed accuracy trade-off suggests that for various combinations of movement amplitude and movement timing that have a constant ratio, the aiming errors are the same, while logarithmic speed accuracy trade-off result from the integration into the plan of movement of consecutive sub-movements.
So we are goal of a movement. We have number 1, spatial accuracy. So it is to move a limb or an object as quickly as possible to a target with a goal of minimal error. So spatial accuracy refers to qualifying errors in the location of boundaries. And number 2, temporal accuracy. It is the accuracy required of rapid movements where timing accuracy is important to task performance. When timing is the goal, speed should be emphasized, timing errors, accuracy errors decrease. So it refers to data that has time components. And we have nature of a movement. And number 1, closed loop. At movement termination, feedback from vision and proprioception needed at the end of movement to ensure hitting target accurately. And number 2, open loop. At movement initiation or the initial movement instructions, sufficient to move limb to the vicinity of target. So the open loop system means the output of the system is free from their input. In the closed loop system, the desired output depends on their input. The open loop system is called the non-feedback system, while the closed loop is the feedback system. Moving on, we have discrepancies in the speed accuracy trade-off. Number 1, quicker movement, where target was closer to coincidence point when movement began, essentially participant having more time to view stimulus or more accurate receptor anticipation. And number 2, rapid movements were more consistent than slower movements, or less variable error VE with rapid movements.
Now, let's proceed to movement timing. What is movement timing? Movement timing is where skills with purely temporal goals seem to follow somewhat different principles than those having purely spatial goals. Decreasing the movement time has the effect of decreasing the timing error from skills with temporal goals and making the movement more accurate in time, not less. It may be defined as the time to complete a discrete predefined motor task. The timing of the task starts at the initiation of movement rather than at the start of a prompt as in reaction time. Next, what is bimanual aiming task? Bimanual feats task is where both limbs could be assigned identical tasks with either low or high IDs, or the limbs could also be assigned a different incongruent task. The explanatory power of Fitts' law is reduced when separate and incongruent task demands are required of two limbs in which the movement time and kinematics for both limbs are not determined independently but rather by a joint command. It was designed to replicate and extend to an integrated feedback condition the pattern of movement time. Let's proceed to continuous bimanual timing. When controlling the continuous movement of two limbs, each with its own spatial or temporal goal or both, because the movements are ongoing, the executive can do the following. First is use common movement command to control the movement of both limbs, and next is switch attention rapidly between the executions of the two tasks.
Coordination as a self-organization process. The motion of motor program is not without its critics. Investigators from the self-organization perspective hold the regularities of movement pattern are not represented in programs but rather emerge naturally out of the complex interactions among many degrees of freedom. Thank you for watching and hope you learn.